This is Bo Boland's final project for EE5143, Design of Digital Circuits. What I did for my final project was the garage door opener. So here's the state diagram that I used for that I implemented for this. Now I wanted to be able to film this video while the state diagram was in the frame, but the video was getting too small and you wouldn't really be able to see the machine, so I'll just have to leave it aside. Now what I did around here is I wrote a little bit, kind of just as a cheat sheet as we go through all the states in the state diagram. This is how I implemented the outputs, because I didn't have a motor to actually hook it up to, or a box to open the module up like you're supposed to do in the self-destruct state. So I just used the up down, the LED 15 and 14 for the up and down, which obviously just controls the motor telling it to go up or down. Pretty self-explanatory. Here's the 16. Actually, I didn't even use all 16 switches, but I used the switches to implement the inputs for the garage door. So this is power up, this is the top and bottom. These would be inputs from a sensor that would tell you if the garage door is fully open or fully closed. Would be a safety sensor. This would come from a safety sensor that tells you if there's something hindering the path of the garage door. This is the self-destruct state, like was mentioned in the project description. And this is the module closed. This signal would come from a sensor on the module that would tell you that once you enter the self-destruct state, it would open, and once you close it, that would be the sensor that tells the state machine that it has been closed. The control key is just 2 digits. What you need is a 10 for the correct control key. Anytime it's not that, it'll enter a different state. And the pin. So what I was gonna do is I was gonna make it so you have to enter 4 16-base digits, anything from 0 to F, and you would have to set them using these 4, and then use this one to send 1 digit in. But I couldn't get them to shift correctly inside of my machine, inside of my code. So really, all you have to do is enter a hexadecimal 5, and then use this button right here to send the pin, and you see the LED will light up. That's just feedback for the user, saying that you have indeed sent the pin. So you just set the pin here, and then use this one to actually send it in. Here's also a little cheat sheet on the button. So I didn't use all 5. I only used 3. So this is the reset, the bottom one. This one is the send pin, like I was saying, and this is the button that actually controls the door. Now the LEDs, one last thing to explain is this is the feedback for the send pin button, like I said, and these last 4, that just tells us what state it's in. So that kind of, I was using for debugging purposes, really all of these, but I decided just to leave them in, really because you'll be able to see as I go through all the states. You'll be able to see that it makes the correct transitions when it's supposed to. So let's go ahead and get started. Let me just set this. We'll start out in the power down state. So you see these 2 LEDs. So the 3rd and the 0th bit of the state machine is set, which means that it is the power down state. So the first state we'll go to from here will be the self-destruct state. So that is entered by entering this one right here. Now, nope, sorry, that is the third one. Yeah, that's the right one. So if you see here, these LEDs are kind of lit, so it looks like it's in the wrong spot. But the reason why it's doing that is because as the clock's going, it's reading that the self-destruct and the module closed is actually it's open. So it's entering the self-destruct state, and it's leaving the self-destruct state and going back to the power down state every other clock cycle. That's what's happening. So what you have to do is you have to set this one, because when you go into that self-destruct state, the module the module will open, and that's what it's showing here. So the module's open, and you need to deactivate that module closed input so that it's not constantly switching states. And when you do that, you see that it enters the right state with the right output. So to get back to the power down, you have to hit the module. You have to take off the self-destruct state, and you have to close the module. So it goes there. It goes back to the module, the power down state. So just again, you hit both of those, it goes into the right state, and then back to power down. So then from here we go to power up state just by hitting the power up button right here, and the LEDs flash, which it's supposed to in this state. Now the first 4 right here are for the pin, the next 2 are for the key, and the correct key, like I said, is a 1 0. So if you enter 0 1, you see it stays in the same state. A 1 1, it'll stay in the same state. It's not until you get to a 1 0 that it enters the deactivated state. Now from here, what needs to happen is you need to enter the correct pin. So like I said, you set the pin using these four switches right here, and you use this button to actually send it to the system. So if I enter 0011 hexadecimal 3 and you send it, let me show you the LED as proof that I'm sending it. So you send it, nothing happens. If I enter an F, doesn't happen either. But when you go ahead and enter a hex 5, you'll see that it goes into the next state right there. Now this is actually 2 states away, because after the deactivated state, it enters the activated state, but from there it automatically goes into the up state. So it looks like it switches the state, but because we're running at 100 megahertz, one clock cycle is so quick that you won't be able to see it. So that's why it goes from 1 to 3. It actually goes 1, 2 to 3, but like I said, you can't see it. So the next thing you got to do here is you got to think about these 2 sensors right here. Now these sensors would normally, you wouldn't have to deal with these in the actual system, like you wouldn't have to set them. But because we don't have sensors here, you have to consciously set these. So because we're in the up state, this top should be set. This top dash L should be set. Now you hit the button and it goes to the moving down state right there, and you see that this LED, which is the 14th LED, which is for down, it is set, which makes sense because it should be moving down from the up state. Now, like I said, you have to make a conscious effort to set these pins, because now you're not all the way open, so this one should not be set anymore. Now the next thing we'll do is we'll go into the stop state, which will happen if you hit this button right here. As it's moving down, it'll stop. So you see it right there, hex 7, and then you hit it again, it should go into the moving up state with the 15th LED lit, and that's what happens. So this is the up state, and the 15th LED is lit. Now when you're moving up or moving down, if you hit it to stop and you hit it again, it should switch directions. So if you're going down, you hit it, it'll stop. You hit it, it'll go back up. If it's going up, you hit it, it'll stop. You hit it again, it'll go back down. So that's what we'll see. I'll just hit it a few times just as proof. So it stops, now it's going down. It stops, now it's going up. It stops, now it's going down. Now as it's going down, the next state would be the down state, and that happens when the sensor sends a down signal, which is this 3rd switch in. So when we set that, we'll see that all these LEDs will go off, and it'll enter the down state, which is a hexadecimal 5. So you see that there, and then you hit it again, you'll see it'll start going up. But remember, you're not in the down state anymore, so you have to hit this one. And to to go back into the upstate, you have to send a top signal, which is this one right here. You'll see that it goes back into the top signal. Hit it again, and then go back into the downstate. Hit it again. Now you're moving up. Now you're in the upstate again. So I mean, that's just let me go to my state diagram again. So that was just me running around. So I started here. I went through here a few times just to show it's working, and then I went all the way around here just a few times just to show that I am actually hitting. Sorry, that's a safety error. It's actually going down here. So I am hitting all the states that I should be hitting. Now the last one is this safety error. That's the safety error and the security error that we haven't state that we haven't hit yet. So there's two more. So where am I? Okay, so I'm up, stopping. Okay, there we go. So I was up. Now I'm going up right now. I'm in the upstate. Now, this safety error, it's only going to happen when the garage door is actually moving. You can't get into this state from any other states other than moving up or moving down. So right now we're moving up, and this fourth switch in is the safety error. So once I switch it, we'll enter the safety error one. So the motor will stop moving, which means there will be no LEDs on, and it's 8. The state number is 8, so you see 8 lit up, and once we set it back down, it'll go back to moving up. So that's what we see right there. Now the last state we got to enter is the security error state. So that's what happens there is so if we remember, these two switches are the control key. Now these 4, it's a little different. The pin, you actually have to set it and then hit a send pin, but because the control key was only 2 bits, I didn't really feel the need to make a send key button, if you will. So anytime you move any of these, it'll send it. It'll send an update that the control key has changed. So whenever you get to this, and whenever you hit the wrong control key, you'll enter this state, which is just an F. And this is the one I was saying it skips. It goes straight to F. And I did that because I wanted it to stick out that, oh, this is the wrong control key, or what you're using is the wrong control key. So that's what I did. So what I did for the security check is I have it on the counter, and I think it counts like 1,000,000 or something like that. And once it reaches the count and the control key is correct, it will go back to the deactivated state. So let me see right here. So you'll see I set it, and it took a little while because it was still counting. So you see that. So that's it entering the security error state. And that's it going into the deactivated state. Now, it's important to show the difference between the power up state and that security state, because the power up state blinks, the security state is just a solid F. So that's all the signals. That's all the states that I was supposed to run through. So that was the garage door controller project by me, Bo Bolin. Thank you.